Okay, solving inequalities. If we have a look at this question, it's a little bit more unusual because x is, as we kind of say, is sandwiched in between two answers. So we can see that we would like to get x on its own. So x is currently not on its own. We'd like to get it on its own, but it's between two values. So I would like our answer to look like this, and x on its own. So remember, x has been times by 2. You can imagine it as balancing equations, but only this time you have to do it to both sides. So if you imagine hiding the first part of the question, thinking of 2x is less than 20, the first thing you'd need to do to get x on its own is to just divide that side by 2, and you'd do the same to both sides. Now if you just focus on that side, that will say x is less than 10. But then the only thing to remember is you have to do the same to all parts of the equation. So I'd also have to do the 12 divided by 2, and that's going to give me 6. So that gives me my final answer there. X is on its own now. It's just between the values. We've got x is less than 10. We've got the less than part there. So x is less than 10, but x is greater than 6. So if we imagine that on a number line, just so we can make sense of it, we've got 6, 7, 8, 9, 10. X has got multiple values. X is less than 10, so it's less than this way, coming that way. And x is greater than 6, so there's where 6 is, and it's greater than this way. So it's all of the values between there. So on a number line, this is how it would look. It would literally be a circle at the 10, a circle at the 6, and just a straight line between, saying it's all of the values in between. Remember, they would not be coloured in because they didn't have the including values on the symbol. So if the symbols look like that, then obviously you might have to shade one of the colours in depending which side it was with. We'll do an example like that now, and we'll change it slightly. So let's have a look. Imagine the question was in the middle this time. We've got 2x plus 3 is less than 23 but is greater or equal to 19. So we do the exact same methods that we've previously done, balancing all parts of it, and if you focus on the middle to get x on its own, you just need to think of the stages you need to go through to get x on its own. So the first thing we can do to eliminate the plus 3 is inverse to minus 3, and all three parts. So 19 minus 3 is 16. That leaves us with 2x in the middle, and remember it's the equal part to it as well, so copy the symbol down. 2x is greater or equal to 16 but is less than 20. We still haven't got x on its own. We need to divide by 2, do it to all three parts, divide by 2. X is greater or equal to 16 divided by 2, which is 8, but is less than 20 divided by 2, which is 10. So I'll move it up a little bit so we can see it. That's our answer there. X can be any of the values between 8 and 10, where the 8 can be included but the 10 is not. So on a number line, let's say 8, 9, 10. The 8 is included, so the 8, if we were representing it on a number line, would be coloured in. And it goes all the way to the 10, but the 10 is not included, so we do not colour that in. If you're asked to state the integers which satisfy it, that means say all the numbers which x could be 8 or 9, because they're the only whole numbers that satisfy the equation. The 10 would not be included because it is not included in the question. Remember, that is only if the question says what integers satisfy the equation.